Okay, let us learn about angle theorems in circles. Let me define the angle at first. What is an angle? So here I have one line segment, or you can also call it as a ray. Let me go ahead and draw one more line. These are the two line segments. Precisely when you define an angle, we can consider a ray also. You can call it as a ray. This is another ray. Both of them have the common endpoint. So at this common endpoint, they are subtending an angle. So this is the angle that is formed between those two rays. Now, those two rays, you can also call them as the sides. Those are the sides of the angle. Further, you can also say it as one is the initial ray and the second one is the terminal ray. And the common endpoint for those two rays is called as the vertex. So vertex is that common point between the two sides of a given angle. In this case, between those two rays, or you can also have segments. That's all right. So now in this figure of a circle, we have two chords. We know the meaning of a chord. You know that a chord is a line segment joining any 2 points of a circle. Here, this is one point on a circle, this point and that point. Those 2 points of a circle are connected. So you got a segment, and that segment is called as a chord. So you can draw infinite number of chords in a circle. Here, in this particular case, we have those two chords having one common point. And because it is a chord, that endpoint is on the circle. So this angle, which is subtended between those two chords, is called as the inscribed angle. Okay, so inscribed angle is an angle whose vertex lies on the circle and whose sides are the chords of the circle, right? So this vertex is so very important. It has to be on the circle in order to get inscribed angle. Okay, that's one thing. Now second, we have central angle. The word itself, the central, it tells you something about the center of the circle. So if the vertex of the angle is at the center, so central angle is an angle whose vertex is at the center of the circle. So we have an angle here. For this angle, the vertex is at the center, hence you call it as the central angle. Of course, the two sides are the radii. In this case, this is one radius and the other radius. So we have central angle. Now, the third word is the intercepted arc. Intercepted arc, you're saying. So it is an arc. Arc means it is a part of your circle. That circle is, so part is taken here. So this green piece is an arc which is intercepted between the two chords which are obtained there. This chord, first chord, and the other chord. The two endpoints are over here, this point and the other point on the right. So between those two endpoints, whatever region, whatever the piece of a circle you have, that is called as intercepted. Now all these three have measures. Like inscribed angle, it has a measure, maybe 30 degrees or 35, whatever it is. We'll see the relationship in a minute. In the same way, central angle also has a measure. Even the intercepted arc is measured in terms of degree measure. Like if it is degrees, say 360 degrees, the whole circle, the measure of the whole circle is 360 degrees. So the measure of this arc will be anything less than 360. For example, if I call this as an arc AB, So to denote or to represent the measure of this arc AB, I have to write measure of AB, like AB, and because it is an arc, above that AB I have to draw a curved line. Please remember that I have to put a curved line to give the measure of an arc. So measure of AB, it can be something like, let us say 120 degrees or whatever measure you have. So if the measure of the arc is 120 degrees, so at the center, this measure of the central angle will also be 120 degrees only. But the measure of inscribed angle, it is going to be half of this 120, which is 60 degrees. Okay, so now let me give this symbolic representation. I'll call this as O, and let me take this as a C. So the measure of angle, see here I'm writing angle here, angle AOB. Where is angle AOB? This angle A, O and B. The measure of angle AOB is 120 degrees. And ACB, the measure of angle ACB equal to, see this is A, C and B, which is half of 120, that is 60 degrees. Now in this figure we have intercepted arc is 100 degrees. So central angle, the measure of central angle is also 100 degrees, and the inscribed angle will be half of 100. So I can write here 50 degrees. This is 50. Exactly, it should be on the circle over here. That is 50 degrees. Here, not only at this point, anywhere I go on the remaining part of the circle, from that leaving this intercepted arc, you go anywhere, this measure will be half of that intercepted arc. If I have 100 degrees for this intercepted arc, the inscribed angle must be 50 degrees, exactly half of that. Let me draw one more inscribed angle here. This measure is also 50 degrees. Alright. Now in the other one here in this figure, let us say they gave us this angle. Its measure is 42 degrees. Okay. If the measure of this inscribed angle is 42 degrees, then what is the measure of intercepted arc? Like we know, if we have 50 degrees here, the inscribed angle, central angle and the intercepted arc has to be double of that thing. So 42 degrees I have here. So what is 2 times 42? 42 times 2 gives me 84 degrees. So the measure of this arc, the arc from this end point of the chord to the other end point, is 84 degrees. Alright. Okay, in this figure we have the measure of this inscribed angle ACB is 53 degrees. Now the question is, what is the measure of the other inscribed angle ADB? This ADB is equal to how much? And what is the measure of this arc AB? What is arc AB? So how do you figure out? Like we have seen in the previous slide, always the inscribed angle is half of the intercepted arc. Here if this is 100 is the intercepted arc, 50 degrees is the inscribed angle. In this example, if 42 degrees is the inscribed angle, intercepted arc is 84. So in this problem, I have 53 degrees as the inscribed angle. So my intercepted arc, this intercepted arc will be equal to how much? It is 2 times 53. So I'll do 53 times 2, which is equal to 106 degrees. That is the measure of arc AB. So the measure of arc AB equal to 106 degrees. Right here, this measure is 106 degrees, I wrote here. Now, with reference to this arc AB, now I can say this angle D is an inscribed angle for the same arc AB. And this measure of arc AB is 106. Hence, this angle D must be equal to half of 106, which is 53 degrees. In other words, whatever angle you have here, there also you get the same angle, 53 degrees, because this intercepted arc is the same for both the angles over here. This the measure of angle ACD and the measure of angle ADB. They both are same. Because of this reason, the measure of arc AB is 106 degrees. Now coming to this semicircle here, what is the angle in semicircle? So this is a semicircle, and in that we are looking at that angle at this point. What is its measure we want to see? How much is that? You know, this is half of the circle. This whole piece is half of a circle. We know the whole circle is 360. When I divide that by 2, you got 180 degrees. So the measure of this arc is 180. So the measure of the inscribed angle must be how much? 180 divided 2, which gives me 90 degrees. So very, very important point. An angle in a semicircle is always a right angle. Anywhere in the semicircle you take that inscribed angle, it will be a right angle only, because this is 180 here, this is 180, so half of 180, there it is 90, here 90. So anywhere an angle in a semicircle is a right angle. So an angle in a semicircle is a right angle. That's very important. Okay, let me also demonstrate this relationship between inscribed angle and intercepted arc. So here in this figure I have, this is the intercepted arc and you have inscribed angle 60 degrees there. Now because the central angle is 120, intercepted arc is also 120 degrees measure you have. So now anywhere you go on this circle, you look at the measure, it continues to be 60 degrees. Let me move over there. Anywhere here it is 60, there it is 60 degrees. Now go farther, in this end it is 60. Central angle is 120 degrees. So the inscribed angle is 60 degrees and the measure of intercepted arc is also 120 degrees. It will be just the same all over. Alright, now let me give you a problem for you to try it out. I have 3 problems in fact. In this, given the measure of intercepted arc, you have to find the inscribed angle, and in the second figure they gave us inscribed angle and you're looking for the intercepted arc. But in this third figure you are looking for the inscribed angle but there is no intercepted arc. But you can find the measure of this intercepted arc by taking away the measures of these 2 arcs. This is one piece and the second piece. Take it away so that you'll get the measure of this third piece. That is, you know that the whole circle, the measure of the whole circle is 360 degrees. From 360 degrees, take away those 2 pieces to get the measure of this arc. And once you have the measure of this arc, you can very easily find the inscribed angle. Please try. Thank you.